Okay, so we've just now finished up problem number 8A, and we're going to take a look at problem number 9. So this one's a little bit more complicated. It looks like we have a cone sitting on top of a cylinder. And so there's going to be 3 pieces. Remember, we're only finding the area of things that are on the outside. So imagine if this shape was made, for example, out of metal, and it was all together in one thing, there would be 3 pieces. There's the circle on the bottom, and then there's the outside part of the cylinder, and then there is the round part of the cone. So we're not able to touch the circle that's the top of the cylinder, for example. So the first thing we can find the area is the circle that's on the bottom. We know that the area of a circle is pi r squared. So we have pi times 3 inches squared, and that gives us 9 pi square inches. Okay, next, I always think of the outside part of a cylinder as being the label of a soup can, for example. And so if I unfolded that, that would make a rectangle. And the area for that rectangle will be the circumference of the circle times 10 inches. And the circumference of the circle is 2 pi r. So we have 2 pi r times 10 inches. And r is 3 inches. So I have 2 pi times 3 inches times 10 inches. And that gives me 60 pi square inches. And then next, we're going to be doing the outside part of the cone, not the circle, but the other part. So we're doing the outer part of the cone, and we have from the last slide, the formula for the surface area of a cone is A plus 1/2 CL. We don't need the A, the circle part. We're only going to use the 1/2 CL part. Okay, and so we have 1/2. C is the circumference, which is 2 pi r, and L is the slant height. We can tell from the picture that's 5 inches. So we have 1/2 times 2 pi times 3 inches times 5 inches. And the 3 inches is because the radius is 3 inches. The 1/2 and the 2 cancel out, so we get 15 pi square inches. And then next, we just need to add up the 3 different areas. So the area for the circle was 9 pi square inches. The rectangle part was the 60 pi square inches. And then the top was the 15 pi square inches. And that comes out to be 84 pi square inches. And if you use your calculator with the pi button, you'll get 263.89 if you round. Did anybody? Okay, so let's go ahead and take a look at the next one. We're going to skip to problem number 11. I know it looks like a circle, but I'm pretty sure we're doing 3 dimensions, so it's actually a sphere. And the formula for the surface area of a sphere is S equals 4 pi r squared. And since the diameter is 12 centimeters, the radius is 6 centimeters. So we just plug in 6 centimeters for r. So we have 4 pi times 6 centimeters squared. That gives me 4 pi times 36 square centimeters, or 144 pi square centimeters. And if you use the pi button on your calculator, that's approximately 452.39 square centimeters. Everything's still going okay? All right, let's take a look at the next problem. It says, which has the largest surface area? A right circular cone with the diameter of the base being 1 and a height of 1, or a right circular cylinder with the diameter of base being 1 and a height of 1, or a sphere with a radius of 1. So we need to figure out the surface area for all three shapes and figure out which one's the biggest. Okay, so we're going to work with the cone first, and we know to find the surface area, we need to figure out its slant height. And so we're going to use the Pythagorean theorem. Okay, we know that its diameter was 1, so that means its radius is going to be 1/2. So I think I did not use the radius being 1/2. So I might need to come back and look at that one again. I did go ahead and use the formula. So I did pi r squared, and again, I plugged in 1 for r, but it says that the diameter is supposed to be 1. So I need to come back and fix that one. And then for the cylinder, this one I did correctly. So its surface area is 2 pi r squared, and r is 1/2 because its diameter is 1. And I plugged in r equals 1/2 here for the 2 pi r, and then its height was 1. So for that one, I got 1.5 pi square units. And then the surface area for the sphere, I plugged in 1 for its radius, and so I have 4 pi square units. So I just need to come back and fix surface area of the cone. Anybody have any questions on that one? Okay, I'm going to pause the recording again.